Hi guys, uh, it's a new topic for the day, which is our shortest distance of a point from a line and foot of perpendicular. So these two things are totally interconnected. If you know one thing, you can figure out second thing easily. So I have considered my line L1. Okay, just in case of example, I have taken xyz as 0 1 2 plus t times 2 1 3 and the point P ABC, from where I would like to find out the shortest distance. Okay, the shortest distance, why it is called shortest? Because from P to A, the point on the line, it is making 90-degree angle. So if it is making 90-degree angle, it has to be shortest, otherwise it will not be shortest. Okay, so now the concept of using this pattern, like how to find out AP, is we need to find out distance of A to P, or maybe we can say the magnitude of vector PA or AP, whatever, because magnitude doesn't matter in which direction you go. Okay, so this is my target for this page. So what you have to do, or what you have to use, first of all, if you want to know vector AP, you should know the coordinates of A, which I have assumed which will be not given to you. So x1, y1 and z1. Since A lies on my line L1, whose equation is already given, so x1, y1, z1 can be obtained from x, y, z from the given equation. Okay, so for example, you can say x is 0 plus 2 times t and y is 1 plus t and z is 2 plus 3 times t. Okay, now this is your point A, and point P you already have because it will be given in statement, okay, in the problem. Now what you need to do, you need to find out vector A to P or vector P to A and then its magnitude. Fine. So for example, I will take vector PA. So how to find vector PA? Coordinates of A minus coordinates of P. So coordinates of A to T minus A, whatever, and then T plus 1 minus B, and then 2 plus 3T minus C. Okay, and then you are stuck with T only. If you know T, you can find out magnitude of T. Now to find out T, what we have to do, we have to use the concept of the vectors here, like, because line L1 is perpendicular to vector PA. Okay, so if they are perpendicular, their dot product should be 0. Their dot product is 0. If their dot product is 0, I mean to say the vector PA dot L1 is this vector. Okay, so if you just concentrate on yellow part, 2 1 and 3, this is our parallel vector to the line L1. When you take dot product of PA and 2 1 3, that has to be 0. So using this relationship, we can easily find T, and then once you get T, you can find out magnitude of vector PA. That will be your shortest distance. Okay, so let's take one example and practice this. Remember, I will just summarize for you. Number 1, you have to find out coordinates of A in terms of T, and then to find out T, you have to use dot product. Okay, dot product of two perpendicular vectors, which is 0, and then fourth one is the magnitude. Okay, so if you find out the magnitude, it means you have already got the shortest distance. So here is the example or the problem. Find the coordinates of foot of perpendicular of L1 from the point P, which is 2, 1 and 3, and then the shortest distance of P from L1. So guys, equation is given here and equation is already written. X, Y, Z equals to 2 minus 1 and 1. It could be here, this point 2 minus 1 and 1, which we don't need, plus S times 1, 2 and minus 3. Now according to the previous discussion we had, first thing what we should have as a part of its solution, okay, that we have to figure out point A on the line, which lies on the line. So we are using equation of line. As you see, point X, Y, Z is the general point on the line. Okay, it could be here, here, anywhere. So the coordinates of X, Y and Z will represent the coordinates of A. So here I'm getting from my equation, so X equals to 2 plus 1 into S. Okay, so X, Y and Z, similarly we can get all three, and X would be 2 plus 1S in means S, and negative 1 plus 2S, and 1 minus 3S. Okay, now we got A. Now let's find out vector PA or AP. Okay, so vector PA means the coordinates of A and minus coordinates of P. So I'll do here vector PA. So vector PA is A minus P. So A I already have, which I got from equation 2 plus S minus 2. So 2 plus S minus 2. This 2 is coming from here. Okay, this 2 is coming from here. And this 2 plus S is coming from A. Okay, so don't worry, A minus P, that's what I said. So similarly we can have another one, the Y component 2S minus 1 and minus 1. Yeah, third one is negative 3S plus 1 and minus 3. So here I got my vector PA. Now why I got vector PA? Because I want to use PA dot product with vector L1 or parallel to L1, which is 0. The dot product of two perpendicular vectors is 0 because the parallel vector of L1 and my line AP or vector AP or PA, they both are perpendicular, therefore dot product is 0. So let's apply this and figure out S. So once you got S, you can find out foot of perpendicular for the coordinates of A, because you need to plug S value here to find out A, and if this is shortest distance, then we will find out distance between A to P. So the key point is find out S first. So to find out S, we will use this relationship PA dot L1 equals to 0. L1 I mean the parallel vector to the line, which is 1, 2 and 3. You can see here I'm highlighting with yellow. So 1, 2 and minus 3, that would be used as parallel vector to L1. And vector PA is, we already got from here after subtracting the coordinates of A and P. Let's continue the calculation. So 2 minus 2 is 0, so I'll just write down S here, and 2S minus 2 and negative 3S plus 1 and minus 3 is minus 2. Okay, dot with L1 means parallel vector to L1, which I already highlighted in yellow. So you can see 1, 2 and 3. Guys, don't worry about this calculation because you may get a complex calculation, but don't worry, just apply. So how to figure out that? So you just do the parallel multiplication, x component with x, y component with y, and z component with z. Okay, so let's continue with this. So 1 times s is s, and then plus double means 2 times 2s is 4s minus 4, then 3 times 3 is 9s, which is negative, minus 6 equals to 0. Now 1s plus 4, 5s, 5s minus 9 is minus 4s, and negative 4 negative 6 is negative 10 equals to 0. So I can say s equals to positive 10 over negative 4, or just say negative 5 over 2. So don't worry about this value s, because we can convert in decimal also, there is no problem. Now what is left for us? First part is foot of perpendicular. So for foot of perpendicular, I will just write foot. We need a, and to find out a, I need to plug my values of s into this. Okay, so in 2 plus s and this equation. So I will just plug this value here. So 2 plus s, so minus 5 by 2, and negative 1 plus 2 times negative 5 over 2, and 1 minus 3 into negative 5 over 2. Okay, so I got my a as 2, 4 minus 5 minus half, and 2 and 2 cancel, which will be negative 6. 2 plus 15, 17 over 2. Okay, so this is my foot of perpendicular, and once you got a, you can find out vector PA, which is very easy here. S2s minus 2, I will not do that calculation, I will leave it to you. So for shortest distance, I will write here, for shortest distance, just find out vector PA, its magnitude, okay, using the square root formula. Okay, so that's it for the day. You just practice and calculate it and try some other problems. Thank you.